Okay, so this is the first sum that we will be solving with the relative velocity method. This is the easiest sum possible. I have selected this just so that you get quite familiar with the relative velocity method. Okay, so this is the given question. As usual, the first step is to write the given data. I have written down all the given lengths and the RPM of link AB. The next step is to write down what we have to find. In our case, we have to find the angular velocity of link CD. This is the link CD. We have to find out with what angular velocity this is rotating. Okay. So whenever you have to solve a relative velocity method question, the first thing that you should do is to draw a space diagram. You might remember it from your ICR question. What a space diagram is. A space diagram is basically just this diagram drawn properly on your A3 sheet. It should be to scale on your A3 sheet. Okay. So the maximum length that you see over here is 150 mm. Okay. So that is too much. If you remember from your ICR question, I had told you that the diagram should be within 12 centimeter by 10 centimeter. Maximum width 12 centimeter, maximum height 10 centimeter. Within that your diagram should be drawn. Okay. So in this case, the maximum is 150 mm. So we can do a direct thing. We can divide this by 2. So take 1 centimeter is equal to 20 mm. And by that we will get a small enough diagram. So that is what we are going to do. So first of all, write your scale. Okay. So writing our scale over here. 1 centimeter is equal to 20 mm on both axes. Always remember, this scale should be for both axes. It should be same for both the axes. You cannot keep it different. Okay. So first we have to draw a horizontal line of 150 mm. Okay. So 150 mm. Length AB is 150 mm. So according to our formula, it will be 7.5 centimeter. Okay. So drawing link AB. Okay. So this is my link AD. Okay. This is fixed to the ground. Okay. I will just draw on it with a pen to make sure that it is visible to all. Okay. This is my link AD. AD. Okay. This is fixed link. Okay. Okay. So next thing that they have given is link AB is 40 mm. Okay. So sorry, this is AD. Link AB is equal to 40 mm. So 40 mm will turn out to be 2 centimeter, which is at an angle of 60 degree. So take your protractor, mark 60 degree, and it should be 2 centimeter. So marking 2 centimeter. 1. This will be your link AB. This is your link AB. Okay. Then you have 150 centimeter link BC and 80 centimeter link CD. So drawing those two, link BC is equal to 150 mm, which is again 7.5 centimeter, and link CD is 80 mm, which according to our scale will be 4 centimeter. Okay. So as we don't have any angles, we will have to use a rounder. Okay. So first take 4 centimeter from link D, mark arc, and 7.5 centimeter. 1.5 centimeter from B, mark the arc. Okay, so we have our point. Let us join it to both the lines. There goes C, here goes C. Okay, so this becomes our mechanism ABCD. We have drawn our 4R mechanism. Okay, now what they have told us, that link B has a 120 rpm. Link B has an angular velocity of 120 rpm. First, we have to convert this 120 rpm into radians per second. Okay, so we know the formula. Okay, angular velocity of link AB is equal to 2 pi n upon 60 is equal to 2 pi into 120 upon 60 is equal to 4 pi, which comes out to be 4 pi is 12.57 radians per second. Okay, so this is my angular velocity of link AB. Okay, now take a close look at this. Okay, in this question, in this mechanism, A is fixed. So link AB is going to perform pure rotation about this point. I have already taught you in the previous lecture that the velocity of point B will be perpendicular to link AB. This has been covered in my last lecture. Okay, one on relative velocity. So velocity of point B with respect to A will be perpendicular to link AB. Okay, so the velocity will be perpendicular to link AB at point B. So the velocity of B will be in this direction. You might not be able to see it, no problem. I have just marked it with a very light pencil. Okay, I will just mark it with a red pen so that you are able to see. Okay. So velocity of B is in this direction. And what is the magnitude? The magnitude, we haven't decided what is, we haven't removed what the magnitude is. Okay. So because this is performing pure rotational motion, we can use the formula V is equal to R omega. VB is equal to length of link AB into angular velocity of link AB. Right? Velocity of B with respect to A is what? Length AB into angular velocity of AB. Okay, velocity of B with respect to A. For all this, please refer to the previous video, Introduction to Relative Velocity. Okay, so length AB is already known to us, 0.04 meter. Angular velocity AB is known to us, 12.57 radians per second. Okay, so velocity of B with respect to A comes out to be 0.04 into 12.57 is equal to 0.503 meter per second. Okay. Now in relative velocity method, whenever you find a velocity of any r, you have to draw it in a velocity diagram on the sheet, A3 sheet. Okay. So to start drawing the velocity diagram, first you have to mark one point. All this has to be done with a pen, a pencil in your case. I am doing with the pen just so that you are able to see it. Okay. So whenever drawing relative velocity diagram, first fix a point. Okay. Now see, look at this point A and look at this point B. Both these points are fixed. So whatever happens, A cannot move from its place, D cannot move from its place. So velocity of A will always be 0, velocity of D will always be 0. Hence, whenever you mark this first point, you should, all the points which are connected to ground should be written over here. But if here it is a capital alphabet, use a small alphabet. This will be small a and this will be small d. Any other grounds which are present, all should be written over here. In our case, we have only two grounds. Hence, we are writing A and D over here. Okay. So, velocity of B is in which direction? This direction. And what is the magnitude of velocity of B? 0.503 meter per second. Okay. So, 0.503 meter per second means what? It means 500 mm per second. Okay. Now this is too much. We cannot draw this with this scale. It will become 25 centimeter. Okay. So for velocity diagram, we have to take another scale. Okay. This becomes our scale for what? This becomes our scale for space diagram. Similarly, we need another velocity, another scale for our velocity diagram. Okay, scale for velocity diagram. Okay, so the simple, what is the velocity of AB? 0.5 meter per second. We can take 0.5 as approximately equal to 5 centimeter on our scale, right? So what does our velocity diagram scale become? 1 centimeter is equal to 0.5 meter per second on both axes. This becomes my scale for velocity diagram. So, sorry, 1 centimeter is equal to 0.1 meter per second. 1 centimeter is equal to 0.1 meter per second on both axes. So in this case, my velocity is 0.5 meter per second. So it will become 5 centimeter. Okay. And in which direction? It will be in this direction, perpendicular to AB. I have explained this in the relative velocity lecture. So please try and see that video first. Okay. So velocity of B with respect to A is in this direction. I will mark it first. And what is the scale? 1 centimeter is equal to 0.1 meter per second. And my velocity is 0.5 meter per second. So this will be 5 centimeter. Here you go. This becomes velocity of B with respect to A. Velocity of B with respect to A. Okay. Next thing, we have to find out the velocity of C and velocity of D. Velocity of D is 0. We just have to find out the velocity of C. Now we don't have any idea about the velocity of C. So how to progress? You should remember the one point which I had made in the relative velocity video. That velocity of any point with respect to any other point is always perpendicular to the line joining those 2 points. That means velocity of C with respect to D will be perpendicular to line CD. Similarly, velocity of C with respect to B will be perpendicular to line BC. So, if you consider velocity of C with respect to D, it will be perpendicular to this line. So, we first have to draw a perpendicular to this line. Okay. So, drawing a perpendicular to this line. I am drawing it very light and then marking it with red just so that you are able to see. Okay. So velocity of C with respect to D will be in which direction? In this direction. That same thing we have to copy it onto our velocity diagram. This is my space diagram. Copy this onto my velocity diagram. So take a roller scale, put it over here. And with respect to D, velocity of C with respect to D. So first find D point. D point is over here. From here, draw a line parallel to this line. So C will be somewhere on this line. We are not exactly sure where it is, but it will be somewhere on this line. Similarly, if you want to find the velocity of C with respect to B, it will be perpendicular to link BC. Velocity of C with respect to B will be perpendicular to link BC. So we can draw it next. Velocity of C with respect to B will be perpendicular to BC. Okay. So drawing this. Now this will be the direction of velocity of C with respect to B. This is direction of velocity of C with respect to D. This is direction of velocity of C with respect to B. Okay, this is C with respect to B, C with respect to D. Okay, so again keep your roller scale over here. You have to copy this onto the velocity diagram. C with respect to B. So first find B and draw a line. Now this point where both these axes intersect, this is the point C. So this becomes from here to here. This becomes your AC. Velocity of C with respect to A or velocity of C with respect to D. As both are ground, it is same. And this becomes velocity of C with respect to B. This becomes velocity of C with respect to B. Now, what is the value of velocity BC? See, what do we have to find? We have to find the angular velocity of CD. Sorry, we have to find the angular velocity of CD. Now, same as this formula. What will be the formula for angular velocity of CD? See, we can use this similar formula. Velocity of D with respect to C is equal to what? Length CD into omega CD. So if we know the value of velocity of D with respect to C, and if we know the length of CD, we can find out the angular velocity of CD. So angular velocity of CD is velocity of D with respect to C upon length CD. Okay. What is the velocity of D with respect to C? Well, you can measure it over here. This is your velocity of D with respect to C or velocity of C with respect to D. Same thing, only direction will be opposite. You can measure it over here. What is the distance? It is 3.7 centimeter, right? So small CD is what? 3.7 centimeter. But what do we know? 1 centimeter is 0.1 meter per second. Therefore, velocity of D with respect to C becomes 0.37 meter per second. What is length of CD? We know it from here, 0.08 meter. Therefore, angular velocity of CD becomes 0.37 divided by 0.08, and that comes out to be 0.37 divided by 0.08, 4.625 radians per second. Okay, so this is our final answer. So I will be solving another question similar to this one. I again repeat, if you are not understanding why this velocity is perpendicular to this, why this velocity is perpendicular to this, please see the relative velocity video. It will clear up all your doubts. Okay, thank you.